This will be a brief introduction to the Forrest Manufacturing Model 204 vertical blade traveling table saw. I've got some other videos on this type of machine. This particular version though has some nice features. I thought it warranted a brief video. First, a little overview of the Model 204. These are obviously vertical blade bandsaws with a traveling table. The Model 204 is built with two 20-inch diameter blade wheels. These wheels kind of set the geometry of the saw, so your maximum distance from the blade here to the saw's vertical column is fixed at slightly less than 20 inches just based on the geometry of these wheels. This one has a vertical working blade length. I think this was at 27 inches. We can make these taller fairly easily, just stretch them out vertically. The 27-inch number comes from, we make these about as tall as we can and still have it fit inside of a regular dry van for shipping. If I make it taller, it has to go like on a flatbed or something for shipping. So we just kind of hit the height at which it's as tall as it can be before you have to pay another $1,000 for a flatbed or something. But we can make these taller. All these machines are high-speed machines. We run a blade speed of around 3,000 feet per minute. We can bump that up to like 4,500 feet per minute depending on applications. We can set these up for heavier blades. This machine comes with our pneumatic blade tensioning. So you can see up here I've got an air cylinder. The standard 204 uses a screw over spring mechanism for tensioning the blade. Reliable as an anvil, everybody knows how it works, and everybody uses it wrong. Very often what happens is small blades tend to be under-tensioned and big blades tend to be, small blades wind up over-tensioned, big blades wind up under-tensioned. When you have a pneumatic blade tensioning system here like this, the actual tensioning force is set with the air cylinder and an air pressure regulator. So you know as long as you don't mess with the air pressure setting, your blade is tensioned correctly. This machine, the blade is controlled with a electric solenoid valve. So from the panel face here, I can detension or tension the blade if the machine's on. Detension, retension the blade. This machine also includes a blade breakage detector, such that if the blade breaks or it's just not there, we know about it. How this works is we have a switch on the cylinder such that when the cylinder strokes all the way out, we interpret that as a fault. So stop the motor or don't let it start. We also have a low air pressure switch on this machine. If you don't have any air plugged in, you're not going to run. So this machine has our powered table drive. All the 204s have a traveling table. This one though has a traveling table with a power system. Let me check that. Fine. That is controlled from this panel here, as are the rest of the saw controls. So this has a nice little control panel here. Control voltage, or fuse disconnect, control voltage transformer, variable frequency drives controlling the table drive motor. This one just has a magnetic motor starter with overload to control the blade drive. So I can start, stop the blade drive from here. Obviously I can tension or detension the blade. I have an indicator for motor fault. If either the blade drive motor or the table drive motor have a fault, red light, nothing's going to work. And if the blade fault, same deal, get an indication. Then we have controls for the table. We have table forward, table reverse, table stop. And I have two separate speed control dials for the table speed. Table forward speed and table return speed. One way we wind up using this is you're going to find some speed that works for cutting your workpiece. Say 50% of full speed on this machine, that's like 1 inch per second, turns out to be your best speed for cutting the workpiece. Set everything up, turn the saw on, start the table moving, make your cut. The table will keep running either until you stop it with a button here or until it reaches the end of travel, in which case it will automatically stop. We're not going to wait for that. Let's go ahead and stop it. Now, that's your cutting side. When you return to the home position, after you make a cut, when you're setting up for a new cut, we have a separate dial for that speed. And what's going to happen is you're probably just going to leave this at 100%. Table return, because The time it takes for the table to return to the home position is basically dead time in your cycle, so you want it to be just full speed all the time. Goes to the home, what I call the home position, stops, ready for your next cut. This machine also has a laser guideline light control from the panel face that assists in setting up your cut. Basically, bright red light, bright red line shines on your workpiece. If you have a mark or something on your workpiece you're trying to match, line up on the laser, you're good to go. I also call it a safety feature. It's less relevant on this machine, but if you see the red light on your hand, move your hand before you make the cut. We're also going to go ahead on this machine, we're going to mount up a guard. We put a fairly large guard right here, expanded metal mesh so you can see through it, just to keep anybody from getting nosy and too close to the blade. This machine, the position of the upper guide is adjustable. And what we call our crank style socket here. Up, down, duh. The idea here is to lower this to just above the height of your workpiece so you expose the minimum amount of blade, and then the unused part of the blade is guarded and you have the minimum amount of blade exposed between the guides for making your cut. Another nice feature on this machine, we have two rails here, what I call the idler support rail and the guide rail. The guide rail has all the good stuff on it. This has the table drive mechanism. It uses a toothed timing belt as the drive mechanism. These timing belts are just about bomb-proof. They do well with the dirty, dusty environment of working around a bandsaw. They're relatively insensitive to misalignment. They're just durable and good for these kind of long stroke applications in a relatively dirty environment. For the table guide, most of the time we use the square tube as the guide element. We roll on it and we have bearings that track along this tube to serve as the guide. To give a smoother and even straighter travel, we're using 1-inch round rail. And then we have precision bearings running on that. This is basically just serving as the guide element, gives a nice smooth ride. The bearings we're using, they're not the typical type of linear bearings. Most of what you see is the bearings, they look like they have a bunch of little BBs in them. They're very smooth, but they are very delicate. And bandsaw environments are not good for delicate stuff. The bearings we use basically have small cam follower bearings in them. Very high load capacity. It's got I think it's a beryllium copper scraper that runs across the top of the rail to make sure there's no debris, then just rolls along that. Pretty much bomb-proof, insensitive to dust, debris, whatever. It just keeps running. But gives you a much smoother table drive, straight guiding. It's as straight as this stuff is. Only using on the guide rail. On what we call the idler rail, we're using a hard urethane caster. For very precise, very high dollar applications, we'll use this on both. But then you get into the problem of making sure that the two rails are dead parallel and level and everything else. It gets a lot fusser. We do it, it's a lot more trouble, a lot more money. You're basically talking $200–300 a foot for this stuff. So we use it on the guide rail. On the idler rail, just like, as I said, we only use the urethane casters. We can do these, but then we have to have a lot more stuff in here to make sure that these rails stay dead parallel, level everything, because linear rails are very sensitive to that sort of thing. Another nice feature of this machine, can you see it down here? The motor is white. The blade drive motor and the table drive motor are wash down duty for dust proofness, really. I don't expect anybody to point a water hose to this thing, but the wash down duty motors are also conveniently very dust proof. And everything's connected up with a NEMA 4X12 conduit. The application for this specific machine will involve cutting some graphite material. Graphite dust, which bandsaws make, is electrically conductive. If it gets into your motor, that is, if the electrically conductive dust gets into your motor, gets in your control cabinets, it can short things out. So by making everything wash down duty and keeping the doors closed, we can prevent anything bad happening to this machine because of the electrically conductive dust floating around. It's money, but it's cheaper than replacing a motor that burned out due to being shorted out from the dust. That's pretty much it for this machine. This is like I say, a version of the Model 204. We have lots of basic variations on the 204. We can make it taller. We can do different table configurations. We have different drive configurations and controls. But the heart of the saw is the 20-inch wheel machine capable of carrying a 1-inch blade, and then everything else we just add on. So we build these to order. And if you have a specific application or would like to learn more about this saw, please feel free to call or email us at Forrest Manufacturing. Thank you for your time.